Hi there and welcome to tutorial 5 for the Edexcel Statistics 1 A-level module, and this video is on measures of dispersion. As always, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Now in the previous video we talked about range, quartiles and percentiles. Now there's a bit of a problem with that in that it only uses a part of the data. It does give us an idea of how the data is spread out, but again, it will be much more useful if we could use all of the data. So what we're going to look at now is working out the average distance from the mean, because the mean tells us a number which is a best representative of the data, the central tendency of the data. So we're going to look at working out the average distance, and the deviation, or the distance of a data from the mean, is given by the value of that data point take away the mean. And one way of working out this average dispersion or spread is called the variance, and that's what we're going to really focus on today. So if we look at these two data sets here, so I've got data set 1, which has 1, 2, 3, 4, 14 and 30, and data set 2, which has 7, 8, 9, 9, 10 and 11. You'll notice if you work out the mean for both of these data sets, they both have a mean of 9. But if we draw a diagram now to kind of represent where these data points are, something should come to light. So if I use this line here to represent the mean, and then I start dropping the data points, so we have 1, we have 2, we have 3, and I'll add on the rest of the data points as well, so 7 will be in there somewhere, and so on and so forth until I've built up a diagram like so. So now I can see all my data points are actually on this grid here, and if we look closely we can see just how far away these data points are from the mean. So I can visually see how far away my data points are from the mean, and something should come crystal clear here. We can see that the blue points are actually an awful lot closer to the mean than the red points. So even though both data sets have the same mean, data set 1 would have a bigger variance because it's further away from the mean than data set 2. So let's look at how we can calculate the variance. So the variance and standard deviation, which I'll talk about in a second, the variance which is used by this symbol here, which is sigma squared, so it's the small Greek letter sigma, not to be confused with the big letter sigma that we use for summing. That's the big letter for sigma, and this is the small letter for sigma. So, and the variance uses sigma squared, and that is, it is the average of the squared distance between the points and the mean. So if I take a data point and subtract the mean, square the answer, do that for every data point, add them together, and then work out the average. Now this formula here, which we'll use in a second, can actually be simplified to this formula here, which is a far more friendly version. And if you want to remember this formula, which you will need to do for your exam, you need to think about it like this. It's the mean of the squares minus the square of the means. So let's say that again. It's the mean of the squares minus the square of the mean. Now the variance gives us an answer that's in units squared. So if you think about it, if I worked out calculations and I was dealing with centimeters, and then I worked out the variance for that, my answer would actually be in centimeters squared, which is not particularly useful. So we tend to actually put things right by using what's called a standard deviation, and that's very simply done by taking the square root of the variance. So if I take the square root of the variance, that gives me the standard deviation. So you may need to pause the video now and make sure that you copy down all these notes here because they're going to be absolutely crucial, and you do need to know these for your exam. They're not in the formula book. So let's have a look at an example here. So let's go back to our data set 1, and we're going to work out the variance for the first data set, and in fact we'll work out the standard deviation as well. So what I've done is I've actually created a little table here. So I've written down what the mean was. The mean is 9, and we could work that out if we needed to by adding up all these numbers and dividing by 6, because there's 6 data points. So first of all, I'm going to work out what x minus x bar is for each one. So x is 1 in this case, and x bar is 9. 1 take away 9 is negative 8. So do the same for the next one. 2 take away 9 is negative 7. 3 take away 9, negative 6. 4 take away 9, negative 5. And 14 take away 9 is 5. 30 take away 9 is 21. And what we're going to do now is we're actually going to square all of these, and that will get rid of any negative numbers that we had. We didn't want negative numbers, so by squaring we can actually get rid of those. So let's square each one. Negative 8 squared, 64. Negative 7 squared, 49. Negative 6 squared, 36. 25, 25, and 21. So the formula says that we sum up these squares, so add all these squares together and then divide by the amount of data, which in this case is 6. So I'm going to add all these up now. So taking out our calculator, 64 plus 49 plus 36, 25, 25, and 21. And adding them together we get 220. So let's just write that down, 220. So the sum of the squares is 220, and the number of data points is 6. So dividing that by 6, we get a variance of 36.6, let's say 36.7 to 3 significant figures. So the variance sigma squared equals 36.7, and that was to 3 significant figures. Now that we have the variance, we can very quickly work out the standard deviation by just taking the square root of this. So leaving my answer on my calculator like so, I can take the square root of the answer, and that gives me 6.06 to 3 significant figures. So 6.06, and again that's to 3 significant figures. So that's using the first formula for variance. Now we're going to use the more easy formula, the one that I think is the easier one to remember. And remember, it's the mean of the squares minus the square of the mean. So again, we've got a little table here just to help us. And I have each data point, 7, 8, 9, 9, 10, and 11. And the first thing I'm going to do is I'm going to square them all. So 7 squared, 49. 8 squared, 64. 81. 81. 100. And 121. Now for this formula, I'm going to need the sum of the squares. That means I need to sum up all of these answers. So again, taking out our calculator, we get 49 plus 64 plus 81 plus 81 plus 100, and finally 121. That gives me 496. So 496. I also need the sum of the values. So the sum of the values will be all of these added together. So 7 and 8 is 15. 15 and 9 is 24. And 9 is 33. 43, 54. So the sum of the values is 54. And now to work out the variance, I need to do the sum of the squares, so 496, divided by the number of values. I need to subtract the sum of the values, 54, over 6, all squared. So if you set it up like that and then put it into your calculator exactly as you see it. So I'm going to put it into the calculator just like this. So we get 496. Let's just change my calculator out of statistics mode. 496 over 6. I need to subtract, opening a bracket, 54 over 6, and that's all squared. And that gives me an answer of 1.67. So to three significant figures, that's 1.67. 3 sig fig. And then once again, to work out the standard deviation, we just take the square root of our answer. So I'm going to take the square root of the answer, and that gives me 1.29 to three significant figures. So the standard deviation is 1.29. So let's have a look at the variance and standard deviation for this one and compare that. Let's copy that. Compare that to what we had over here. So if we look, data set 1, which was the red data set, had a variance of 36.7 and 6.06, and for data set 2 it was considerably smaller, 1.67 for our variance and 1.29 for our standard deviation. And if you go back to our diagram, you clearly see that the red data points were much further away, hence they had a much bigger variance and standard deviation, as opposed to the blue data set, which had a much smaller variance and standard deviation, which is telling us that the data points are much closer to the mean. And that is what the variance and standard deviation do. So, time for you to have a go. Pause the video now and see if you can work out the variance and standard deviation for each data set. Okay, hopefully you've tried those questions. I'm going to bring up the solutions now and you can mark your work. So for both questions, you may notice that I've used the simpler formula. So I've used the mean of the squares minus the square of the mean to work out both. And all my answers are given to three significant figures. So mark off your work and see how you did with those. If they didn't work out, do check your figures and see if you can figure out where you went wrong. Now, we could also have to work out the variance and standard deviation for grouped frequency distributions, but it's not a whole lot different. So if x is the midpoint when we have a class interval and f is the frequency, then obviously the total number of values is the sum of the frequencies, just like we've done before. So adding up all the frequencies, that will tell me the total frequency. And then to get the variance, we need to do the sum of the frequency times by the difference squared divided by the sum of the frequencies. Now, once again, I would highly recommend that you just remember this formula, because this one is far easier to use than this one. And it's a similar one. It's the mean of the squares minus the square of the mean. And once again, the standard deviation is still the square root of the variance. So let's just have a look at this in action. Okay, so we've got again another grouped frequency distribution, and we need to work out the variance and we're going to work out the standard deviation. So first and foremost, I'm going to actually add a little column in. Now x, remember, is our midpoint. So the midpoint of each class interval, in this case, is going to be 22.5. This one, 27.5. 32.5. 37.5. And 42.5. And then I need to do the frequency times by the midpoint. So taking out our calculator. So 1 times 22.5 is 22.5. 5 times 27.5 is 137.5. 32.5 times 9 is 292.5. 292.5. 37.5 times by 11, 412.5. And then finally 42.5 times by 5 gives us 212.5. And now I need to fill in this column, which is the frequency times by the midpoint squared. Okay, be careful now, it's not the frequency times the midpoint all squared. It's the frequency times the midpoint squared. Order of operations takes precedence here, so you square the midpoint and then times by the frequency. So I'm going to square the midpoint, 22.5 squared, and multiply that by the frequency. So that gives me 506.25. 506.25. 27.5 squared times 5, or 5 times 27.5 squared if you like. 3781.25. Next we do 32.5 squared times by 9. 9506.25. 37.5 squared times by 11 is 15468.75. 15468.75. And then finally 42.5 squared times that by 5. So 9031.25. 9031.25. Once again, just to reiterate, you square the midpoint first and then multiply by the frequency. Okay, so for this formula down here, I need the sum of the frequency times the midpoint squared. So in other words, I need the sum of this. I need the total here. And I'm also going to need the total for this. So let's work out these totals. Starting with this column here, 22.5. So this is the sum of the midpoints times the frequency, 137.5 plus 292.5 0.5, 412.5, and 212.5 gives us 1077.5. So the sum of the frequency times the midpoint equals 1077.5. We also need the sum of the frequency times the midpoint squared. So summing all of these up now. Excuse me. Okay, 506.25 plus 3781.25, 9506.25, 5468.75, and 9031.25. Adding them all together, we get 38293.75. 38293.75. Okay, and now we have everything we need to work out the variance. So sigma squared equals the sum of the frequency times the midpoint squared, which is this. So we get 38293.75 all divided by the sum of the frequencies, which I'll add these up really quickly. 6 and 9 is 15, 15, 26, 31. So we get 31 here. Let's just write that down. Sum of the frequencies equals 31. And we're going to subtract the square of the mean. So that's the sum of the frequencies times x, which is 1077.5 divided by the sum of the frequencies, which is 31, and we need to square that. So we're just plugging numbers into a formula here. Again, take out the calculator, put it in exactly as you see it. So 38293.75 over the 31. And we need to subtract 1077.5 over 31, closing the brackets, squaring my answer, equals, and we get 27.1, say 27.2 to 3 significant figures. So 27.2, and that's to 3 significant figures. And let's work out finally the variance or the standard deviation. So the standard deviation is simply obtained by taking the square root of the variance. So the square root of my answer will give me 5.21 to 3 significant figures. 5.21, and again that's to 3 significant figures. Okay, time for you to have a go. So pause the video now and attempt to find the variance and standard deviation for this frequency table. Okay, hopefully you've tried that. I'm going to bring up the solution now. So I got a sum of f to be 31, sum of fx is 557, sum of fx squared is 10573. I plugged them into the formula. I got 18.2 to 3 significant figures for my variance, and for my standard deviation I got 4.27, again to 3 significant figures. Okay, just one more thing before we finish up here, and that's just to do with coding. So we could have to code as well to find standard deviations or variance. You do the same thing as you do before. You transform all the numbers using the code, and then you just use the formula as usual. Now, a couple of things to note is that adding and subtracting does not affect the standard deviation, whereas multiplying and dividing does affect the standard deviation. So these are two things that you will need to know. So if I can just give you a quick example here, if the standard deviation of a data set using the coding y equals x minus 40 is 2.56, well, that means the standard deviation of the uncoded set is still 2.56. However, if the standard deviation of a set of data using the coding y equals x over 10 is 2.56, well, that means the standard deviation of the uncoded data is I need to undo this division by 10. So that means the standard deviation for the uncoded data set is going to be 10 times bigger than this because it was all the data points were divided by 10. That means the standard deviation is going to be 25.6. So if you divide by 10, with your coding, that means to get the original standard deviation back, you need to multiply by 10. Or if it was divided by 100, again, you'd need to multiply by 100. If it was times by 20, you would have to divide by 20 at the end to get the original standard deviation. Okay, that's all from me. You should now be able to attempt exercise 3C, 3D and 3E from the Edexcel S1 textbook. Do have a read of the chapter as well, and yeah, that's it from me. So hopefully you enjoyed the video and found it useful. Best of luck with the revision, and I'll talk to you again sometime. Thank you.